Hello, in this video I will talk about the pointers to the structures. So here we have a struct which is cat type and it has one field, h. In here I would like to create an instance of cat type. So here I say cat type. Let me give a name, let's say C. Okay, and then I can do this, and then I can also say okay, so let's say printf. Okay, so let me say h. H is an integer, so %d. Okay, and then so let me display the c dot h. So let me just compile it, run it. Okay, it is a garbage because we had not assigned anything yet. So here I will say c dot h and let's say 22. Okay, so now if I compile it and run it, okay, so now it says h is 22. I could also do this instead of doing here. I could say so there is only one field, so I can say 22. So compile it, run it. Okay, h is 22. Let me write a method to display the information of the cat. So here I will say void display cat info. Okay, display cat info, and let's say cat type C. Okay, and let me just copy and paste this, or cut and paste actually. Okay, so here it says h is whatever this. So here let me just call this method display cat info. The parameter is c. Okay, so now let's compile it, run it. Okay, h is 22, and so right now we are passing by value. Let's pass this by reference. So here cat type, so this is a pointer to cat. Okay, so pointer, and in here when we pass, we don't pass as c, but we pass the address location of it, address of c. Let me just compile it and run it. Okay, reference type. Okay, so we forgot to change here. C is not cat anymore. C is a pointer to cat. So I could either do this, the thing pointed by this dot h. So let's see that it works. Okay, it works. Or in short, I can say arrow sign. Okay, just C, and I also notice that I am also deleting this asterisk. Okay, so this one. Let me compile it and run it. Okay, it works. So now let's write. So here, okay, I am allocating memory for this cat statically, which means in the code. So here, at the time of compilation in the code, I should know how many cats I will create. But in the real life, that's not always the case. We determine the number of cats we want to create at the runtime. So for example, you may ask the user, do you want to create a cat? Yes. And then another one, okay? And user may say, okay, I want to create 5 cats. So you don't know how many cats you want to create in when you are writing the code. So this will be, so we want to allocate memory dynamically instead of statically. So let's write so we need to use malloc. So let's write a method here, which will be new cat. Okay, and also as a parameter, let's pass the age of the cat. So we will say I want to create a cat with this parameter age. Okay, and what will it return? It will allocate memory for a new cat, and then it will return the memory location of this cat. So it is a cat type pointer. So pointer to a cat type. Okay. So let me open and close the curly brace. Okay. So here we will use malloc. Okay. And here I need to say how many bytes I need. I will say, okay, whatever is needed for the cat type. So I say size of and cat type. Okay, and remember this returns a pointer to void, and we need to typecast it to cat type pointer. Okay, cat type pointer, and we need to assign it to something on the left. So here let me just have a temporary variable which is a pointer to cat type. So let me say temporary cat. Okay. Okay, so let me just do this so that you can see it. Okay, so here, or let me just say temp. Okay, so you can see all of them. Okay, so here, let's see what this is. So here I will, so before displaying it, before returning it, let me just print it. Print f. Okay, so here I will say in newCat pointer is %p, and then temp. Remember that temp is already a pointer, so we should not say ampersand because we are not interested in the address location of the temp, because temp is already holds an address location of a cat. So don't do this, and also don't use this one. Asterisk means the cat type which is pointed by this pointer, but I would like to see the pointer, the value of the pointer, which is address location. So I use just temp. So let me display it, and also we need to return this temp. Okay, so we are returning it. Okay, so now let's try this. So I am not doing this anymore. Okay, I am not doing it. So let me say cat type. So a pointer to cat type. So let me say p to indicate that this is a pointer. Okay, so here let's assign a value to this, and I will say new cat, and let's say 24. Okay, so this new cat method returns a pointer to a cat type, and on the left side of this assignment operator I also have a pointer to a cat type. Okay, pointer to cat type, and this also returns pointer to cat type. Okay, so this should work. In here, should I just say p? So I am pausing a little bit. No, I should not say ampersand p, because I am not interested in the address location of p. P is already an address location which is which points to a new cat. So just this. Okay, so this is a pointer to cat type. So let's see, display cat info. Okay, it is a pointer to cat type. Okay, So now let me let me compile it. Okay, so implicitly declaring library function malloc. Malloc is in this library on the top. So stdlib. Okay, so here I say include stdlib.h. So let me compile it. Okay, run it. Okay, so it says in newCat pointer. So okay, so in here in newCat, this is the pointer, and h is 0. Okay. Okay, so let me put this one here. Okay, so now let me compile it. Okay, so we did not get what we expected. So what is wrong here? As you see in the newCat, I pass a parameter a, but I am not using it. I have not assigned it yet. So here, after I allocate it, so temp, because temp is a pointer to a cat type, so instead of dot, I use a row sign and h, and let me say a, whatever the parameter is passed. Okay, so now let me compile it, run it. Okay, so this is the pointer, and h is 24. Okay, and as you see, we allocate memory dynamically by using the malloc. I hope this is clear. Have a nice day.